And some of them might be eerily similar to Earth. It's been staring at the same patch of sky for years, watching over 150,000 stars, waiting for the tiniest flicker of light that could reveal something extraordinary. And what it found will blow your mind. Today, we're diving into one of the most ambitious scientific missions ever attempted. And by the end of this video, you'll understand why everything we thought we knew about planets, stars, and even our own cosmic future has been completely rewritten. But first, let me ask you something. When you look up at the night sky, what do you see? Stars, obviously. Maybe the moon if you're lucky. But what if I told you that almost every single one of those stars has worlds orbiting around them? Planets we never knew existed until recently. This is the story of how one telescope launched humanity into a new age of discovery, revealing not just thousands of new worlds, but also the terrifying and beautiful fate that awaits our entire universe. Let's start with the hero of our story. Imagine launching something the size of a small car into space, sending it nearly 100 million miles from Earth, and asking it to detect changes in starlight so subtle they're like noticing a single grain of sand pass in front of a lighthouse beam from miles away. That's exactly what scientists did when they created the Kepler Space Telescope. But here's what makes this even more incredible. Kepler wasn't scanning the entire sky randomly. Instead, it focused on one specific region where three constellations meet: Cygnus, Lyra, and Draco. Think of it as the ultimate cosmic stakeout, watching this single neighborhood of space with unprecedented precision. But Kepler was so sensitive it could detect these cosmic winks. The telescope's mission was deceptively simple in concept, but mind-bogglingly complex in execution: find Earth-like planets around other stars. Now here's where things get tricky. Planets don't produce their own light. They're basically cosmic rocks floating around stars, completely invisible against the blazing brilliance of their parent suns. So how do you find something that doesn't shine? The answer is both elegant and ingenious. Scientists use what's called the transit method. Picture this. When a planet passes between its star and us, it blocks a tiny fraction of the star's light. From these barely perceptible dips in brightness, scientists can determine incredible details about distant worlds. They can calculate a planet's size by measuring how much light it blocks. They can figure out its orbital period by timing how often the dimming occurs. They can even estimate its distance from its star and whether it might have conditions suitable for life. And boy, did Kepler deliver results that shattered our expectations. One of the most fascinating discoveries was a world called Kepler 36b. This planet is roughly 4 times more massive than Earth, orbiting a star remarkably similar to our Sun. But here's what makes it special. Scientists detected hints of an atmosphere surrounding this rocky world. This wasn't just any planet. This was what astronomers call a super-Earth, a type of world that doesn't exist in our solar system but appears to be incredibly common throughout the galaxy. It turns out our solar system, with its neat arrangement of small rocky planets close to the Sun and gas giants farther out, might actually be pretty unusual. Some planets orbit their stars so closely they complete a full year in just a few Earth days. Others are so far away they take centuries to make one trip around their sun. But Kepler did something even more profound than just finding planets. It showed us what these worlds are actually like. The telescope revealed that planetary systems come in configurations we never imagined. Some have multiple rocky planets packed closer to their star than Mercury is to our Sun. Others have gas giants in tight orbits, completing their years in mere days. This data revolutionized our understanding of how planetary systems form and evolve. Now, while Kepler was revolutionizing our understanding of planets, other telescopes were uncovering equally mind-blowing secrets about our own galaxy's history. Enter the Sagittarius stream, one of the most remarkable cosmic crime scenes ever discovered. Imagine a ribbon of stars stretching completely across our galaxy's halo like some cosmic highway. These aren't random stars. They're the remnants of an entire galaxy that our Milky Way literally tore apart through gravitational force. The victim was the Sagittarius dwarf galaxy, and the evidence of this cosmic collision is written in the stars themselves. Thanks to the European Space Agency's Gaia telescope, astronomers can now track the motion of individual stars within these streams, confirming that we're looking at the debris of a galactic merger that happened billions of years ago, possibly even before our solar system formed. But here's the incredible part. This cosmic violence might actually be essential for life as we know it. When galaxies collide and merge, they inject fresh hydrogen gas into each other. Hydrogen is the raw material for star formation, the universe's basic fuel for creating new suns. Without these galactic encounters, star formation would eventually grind to a halt. Speaking of hydrogen, most of it is completely invisible to our eyes, detectable only through radio waves. This invisible gas is literally the lifeblood of our galaxy, flowing through space and condensing into the stellar nurseries where new stars are born. But let's journey to the most extreme environment in our galaxy, the very center, where something so massive and powerful lurks that it bends space and time itself around it. At the heart of the Milky Way sits Sagittarius A star, a supermassive black hole containing the mass of over 4 million suns compressed into a region smaller than our solar system. This is where the laws of physics become almost incomprehensible, where gravity becomes so intense that space itself behaves like a river rushing toward a cosmic waterfall. Around this monster, stars orbit at incredible speeds, some completing their paths in just a few years, despite being farther from the black hole than Pluto is from our Sun. Any planets in these systems would experience conditions beyond our wildest imagination, constantly bombarded by radiation and gravitational forces that would make Earth's most extreme weather look like a gentle breeze. If a rogue planet ever wandered too close to this gravitational beast, the result would be both spectacular and horrifying. The black hole's tidal forces would stretch the planet like taffy in a process scientists beautifully call spaghettification, pulling it apart atom by atom until nothing recognizable remained. But how do these cosmic monsters even form? The answer takes us back to the deaths of the universe's most massive stars, those 20 or 30 times heavier than our Sun. Throughout their lives, these stellar giants maintain a delicate balance. Nuclear fusion pushes outward while gravity pulls inward. But when the nuclear fuel runs out, gravity wins decisively. In a catastrophic collapse lasting mere seconds, the star's core compresses into a point of theoretically infinite density, while the outer layers vanish, leaving behind a gravitational prison so strong that not even light can escape. The star doesn't just die, it vanishes from the universe, leaving behind only the curved space-time that marks its grave. Around a black hole, space itself becomes like a flowing river. Far away, you could swim against the current and escape. But as you approach the event horizon, the current becomes impossible to fight. This boundary represents the ultimate point of no return, where even photons of light are trapped forever. Contrary to popular misconceptions, black holes don't actually suck everything into them like cosmic vacuum cleaners. They only capture matter that ventures too close. From a safe distance, you could orbit a black hole just like any other massive object. Now let me share something that might change how you think about time itself. We are currently living in what astronomers call the Age of Stars, also known as the Age of Light. For thousands of years, humans have navigated by starlight, written poetry about celestial beauty, and found comfort in the eternal dance of constellations overhead. But this brilliant era is temporary. Across cosmic timescales, star formation is already slowing down. The universe's hydrogen fuel is gradually being locked away inside existing stars, or trapped in regions where it can't collapse to form new ones. Nuclear fusion, the process that makes stars shine, will eventually fade as stellar cores cool and die. Our own sun, currently about 4.5 billion years old, has roughly 5 billion years of hydrogen fuel remaining. When it exhausts this supply, it will expand into a red giant before eventually cooling into a white dwarf, a stellar corpse about the size of Earth but containing most of the Sun's mass. The smallest stars, red dwarfs with just a fraction of our Sun's mass, will continue burning for hundreds of billions of years, far longer than the universe has even existed so far. But eventually, even these cosmic lighthouses will fade to black. The Age of Light represents just a brief moment in cosmic history compared to the infinite darkness that will follow. This might sound depressing, but it actually makes our current existence even more precious and remarkable. During our search for other inhabited worlds, we've detected something both mysterious and hopeful. In our brief cosmic lifetime, we've listened intently for signals from other civilizations and heard only silence from the stars. Yet hope persists in unexpected places. In 2020, astronomers discovered something fascinating. A rogue planet nearly the size of Earth, drifting alone through interstellar space without any star to call home. This lonely world raises intriguing questions about planetary formation and survival. Was it ejected from its birth system during some cosmic catastrophe? How many such wandering worlds exist in the darkness between stars? Most stars in our galaxy aren't solitary like our Sun. Instead, they exist as binary pairs, locked in gravitational dances around each other. A planet in such a system would witness double sunrises and twin shadows, experiencing day and night cycles unlike anything we can imagine on Earth. But these stellar partnerships can be unstable. Gravitational interactions can twist planetary orbits into chaos, sometimes flinging entire worlds out of their home systems to wander the galaxy as cosmic refugees. Despite the universe's apparent indifference to our existence, humanity continues pushing the boundaries of exploration. In 2018, NASA launched one of the most audacious missions ever attempted, the Parker Solar Probe, designed to actually touch the Sun. This incredible spacecraft, launched aboard a Delta IV heavy rocket, follows a trajectory that brings it closer to our star with each orbit. Over the course of 24 carefully planned approaches, Parker will eventually dive through the solar atmosphere itself, enduring temperatures that would instantly vaporize most materials while traveling faster than any human-made object in history. By studying how our Sun releases its energy and creates the solar wind that fills our entire solar system, Parker helps scientists understand not just our own star, but the fundamental processes that power all stars throughout the universe. In a very real sense, this mission is helping us understand our own origins. Thanks to the Hubble Space Telescope and other instruments, we now know that our universe is not only expanding but accelerating, driven by the mysterious force we call dark energy. If we could run time backward like a cosmic movie in reverse, we'd see galaxies converging, stars disappearing, and all matter condensing into increasingly smaller spaces until everything we know compressed into a single, infinitely hot and dense point. This moment, the Big Bang, occurred approximately 13.8 billion years ago and represents the beginning of everything we can observe or measure. The newborn universe was a cosmic furnace where temperatures and densities exceeded anything we can replicate on Earth. Decades after that primordial explosion, European scientists launched the Planck telescope to detect the faint afterglow of creation itself. This ancient light, stretched and cooled by billions of years of cosmic expansion, still whispers across space, carrying the story of how everything began. From Kepler's patient vigil over distant worlds to our bold attempts to touch the Sun, from the cosmic violence of galactic mergers to the serene mathematics of planetary orbits, the universe continues revealing both its vast scale and intimate connections. We exist during a remarkable cosmic moment when stars still shine, planets still form, and life has the opportunity to evolve and contemplate its own existence. The universe took nearly 14 billion years to create the conditions that allow us to build telescopes, decode starlight, and discover worlds beyond our dreams. As you finish watching this video, remember that you're part of this incredible cosmic story. The carbon in your body was forged in the hearts of ancient stars. The oxygen you breathe came from stellar explosions that seeded space with the elements necessary for life. You are literally made of star stuff, temporarily organized into a form capable of understanding the very processes that created you. The next time you look up at the night sky, you'll know that almost every star you see likely hosts its own family of worlds. Some might be rocky like Earth. Others might be gas giants with diamond rain and metallic hydrogen cores. A few might even harbor conditions suitable for life as we know it. Thanks for joining me on this cosmic journey. If this video changed how you think about our place in the universe, make sure to like and subscribe for more mind-bending explorations of space and science. And remember, we're all passengers on a small rocky planet, orbiting an ordinary star in an unremarkable galaxy. But that makes our ability to understand the cosmos around us absolutely extraordinary. Keep looking up and keep questioning everything. The universe still has countless secrets waiting to be discovered, and who knows what incredible revelations await us in the years to come.